Good morning everyone. There are four main components for a large language model. As you can see here, we have the transformer architecture, we have the tokens, we have the parameters and the context window length. And when we talk about large language models, we almost refer the size of the model. Like GPT-3 has 175 billion parameters, LLaMA 2, the biggest of the LLaMA, they have 70 billion of the parameter. What is this 70 billion parameters? And coming to that, parameters are the variables that the model learns during the training process, and they get adjusted during the training process. And why this happens? Because for a given input during the training process, you want to try and minimize the difference between the predicted and the actual output. Let me give you an example of a neural network and how does the parameter come into the picture. So in this next slide, what we are going to see is this is a neural network. They contain of an input layer and an output layer, and in the middle there is something called as a hidden layer. This is a visual representation of a neural network, and you can see the architecture has different layers, and the node is represented by a circle in the graphics. It receives input from the other nodes that are there. It processes it and then passes the output to the other nodes. So a node represents the neurons and the collection of nodes or neurons is known as a whole neural network. The input layer has 3 different nodes, the hidden layer has 4 nodes, and the output layer has 1 node. This is a connected network. So we will understand what is parameter in this particular scenario. And as you can see, there are between the input between the two different layers, there are connections, and they are calculated by weights. So weights is equal to inputs and biases. But the thing is, what happens is that there is always a term of biasness, because it is not exactly equal, right? The number of parameters is not only always equal to the number of weights, but also it is equal to the number of weights plus the biases. So here I'm going to give you an example. So what is happening is, from the input layer on the left, there is a line from every node in one column or the layer to all the nodes in the other layer. This type of neural network usually makes a small part of the large language model that is there, and each of the lines connects one node to the other node are the edges, and they represent the weights. And this network learns by adjusting those weights. The network that is there, it learns by adjusting the weights, and we can easily calculate the number of weights, as you said in the earlier slide, by multiplying it by the input to the output. And what happens is, the weight associated with the connection won't give us an accurate result when trying to fit or train our model with the data. So we need an offset to adjust every term for the node, and in this example there will be 4 in total. This means for this particular scenario, if you can see here, it will be 3 into 4, because this is the weight plus 4. So here it is going to be 12 plus 4, it is going to be 6. So for this diagram, the total in this particular scenario, this you can see that the number of parameter is 3 times into 4 plus 4, which is a total of 16. We apply the exact same logic to the next part of the network, which is the middle section, and we have 4 nodes on the left and 4 on the right, and this means we are going to do the calculation and get the whole node here as well. So in this scenario, in the first case, what is it going to happen? 3 into 4 plus 4, and this is going to be 16. In this scenario, in the second node, it is going to be 4 into 4 plus 4, because we have in the left layer we have 4 nodes, and in the right 4 nodes, and 4 for the bias. So this is going to be 16. 4 into 4 is 16 plus 4, that is 20. Here it is going to be 3. Here there is only 1, so 4 into 1 plus 1. So here it is going to be 5. How we are coming with 41 is, we are adding all the weights that are there. 16 plus 20 plus 5 is equal to 41. So this particular thing is a 41 parameter model. I have given a quiz in our community a few days back about the same network and asking for the parameter. So this is the way we calculate the parameter that is there. And to give you a sense of perspective, most large language models, LLMs like GPT-3, LLaMA, they have several billion parameters, and they consist of lot of layers, lot of nodes, and lot of you can say connections like this. So this is a completely connected network, and this is the way we calculate the number of parameters. So looking forward for more such informative videos in the coming days.